This video is actually for an econometrics class, but I think it could apply to any um, regression. This is from the Gujarati and Porter Essentials of Econometrics book, and it's table 4-6. And we have a list of countries, and we have, what do we have here? We have education level, how much they spend on education, their GDP, and their population. So we probably want to see, the variable of interest is no doubt GDP. We'd like to be able to predict GDP. So that's going to be the dependent variable. And we have two other variables, population and education level, or education spending, that we can use to predict GDP. In this video, we're going to only try to use one variable to predict it. We have education and we have population. My guess would be that education is probably more important than population. But we will do the simple linear regression for both. And we'll be using Excel, which has the most, probably the easiest linear regression for just to do right off the top of our head, to do a quick and dirty study. So let's look at this. First of all, if I want to graph population and GDP, I just highlight the two columns. I say insert. I do a recommended chart, and I come up with a scatter diagram. And we see that it doesn't really look like much. A lot of data is clustered close to the 0, 0. And then we have points that are out here. This point out here will influence, the farther out that kind of point is, it will influence the line. But if we want to do a quick linear regression, I go here to this quick layout. I click on it and see where it says f sub x. I click on that and it actually gives me the regression line. So it says, the x-axis, which we probably should label, is what? Population. Population in I don't know what the population is. Where's the U.S. on here? It's not on there. Guatemala is probably in millions. I doubt Belgium's population is 232 million. That sounds like a lot. We'll just call it population then. And then in the y-axis, we have GDP. So I'm not worried about I'm going to get rid of that. So if we look at this here, and if I want to make this bold, I could do it. And I could even make it bigger. I could make it a little bit bigger, easier to read. So it says that if I want to predict the GDP based on a country's population, it would be 2,461.1 times the population plus 483.93. And the R squared is 20.2091 or 20.91%. Now, the thing about that is, it says that 20% of the variation in GDP is explained by this model. Okay? Is it a good model? Is it a bad model? I don't know. It doesn't look that great to me. I'm only explaining 20% of the variation. I don't know how happy I am about that. But when I look at the scatter diagram, it just really visually doesn't look like a good fit. You can only do the visual interpretation. Let's call this GDP versus population. And I think all of your graphs should be labeled very nicely like this. Okay, so let's try the other one. Let's try education. Now I have to highlight education separately. And then I probably hit like the control key and then highlight GDP. Oops, I'm on a Mac. Probably behaves differently. I probably got to do the command key to do that. Yes, I do. And that's not working well. There we go. Okay, so I highlight those two. Now I go again to Insert. I go to Recommended Charts, and I do, I plot that. Now you can see this is clearly a superior chart, just from the scatter. I mean, it already looks linear. I would say if I had to pick between trying to predict GDP by population, using population to predict it, or education to predict it, education certainly seems like the better choice. So I'll do the same thing. I'll go to Quick Layout, and I'll put my little f of x equation in there, and I'll bring that up here. There's not many lines, so I know that the dots are the actual GDP, and the dotted line is the linear regression. I don't need the key, really. And I'll just label the graph the same. This is called education spending, and this is GDP. So this is GDP versus education spending. And I got a nice little graph. Now, if we look at this, one, visually it looks really good, and two, the R squared is also very, very robust. It's showing 0.934, or 93% of the variation in GDP is explained, in fact, by education spending. So there we have it. Very simple linear regression using a graphical technique in Excel, and that's about all you really need to look at a very simple level. It gives you a scatter diagram, and it gives you the regression equation and the R squared. If you want to find the Pearson correlation coefficient, coefficient of correlation, here's R squared, and then here's R. So if I have 0.2091, the square root of that, SQRT, gives me the Pearson correlation coefficient. And let's express them as percentages to one decimal place. So you can see that the R, which is the correlation coefficient, is not really compelling, and if we look in the case of the other one, let's make that the title's bold, where it's 0.93, where it is 0.934. Sorry, I had a phone call. That happens on occasion. So if I copy that down, you'll see that, wow, the R is also 96%, which is really impressive. So I would probably go, if I only had to use one variable to predict it, and these are the only two variables I was considering, I would definitely use education spending. All right, thank you very much, and we'll be right back at you with another video on this subject.